So, what is frequency? So, by definition, it's a formula, and it's the number of oscillations per second measured in hertz. So, frequency actually plays a significant role in determining the behavior of waves. We'll come back to waves in a minute. It's a measurement of how often a recurring event, such as a wave, occurs. Well, it could be a sound wave, and it can be a light wave, and it's in a measured amount of time. So, frequency is one way to define how fast a wave moves. The speed of propagation of a wave is related to its frequency and wavelength. And the equation is this. So speed equals frequency times wavelength, where v is the speed of propagation, f is the frequency, and that upside down y thing is called a lambda, and that's wavelength. So from that relationship, we can see that in any medium where the speed of propagation is constant, so where speed is constant, the higher the frequency, the smaller the wavelength. Now in sound waves, which is what we're going to focus on a little bit today, the higher the frequency corresponds to a higher pitch. So a higher pitch in sound is a higher frequency. And then in light waves, higher frequency corresponds to the color blue, or blue colors, shades of blue. The frequency of a wave also affects how it interacts with obstacles and boundaries. So, waves with shorter wavelengths, such as high frequency waves, they're more easily diffracted, meaning they can bend and they can move around obstacles. Okay? And they could also spread out when passing through something narrow. Waves with longer wavelengths, such as low frequency waves, they tend to travel in a more direct path and are less likely to divide or diffract. Every physical system, so that means from a string to a cell, has a natural resonant frequency. That includes the computer I'm typing on, that includes the space around me, that includes everything in the space around me, that includes nature, that includes a leaf on a tree, that includes the tree itself, that includes us individually as have a frequency, every cell in us has a frequency, every organ in us can have a range of frequencies, and so everything is frequency. And frequency is biological and it's physical. And it's what's responsible for the behavior of that wave that we just spoke about. And frequency is in light, in sound, in electromagnetic fields, it's in biological systems, and we are immersed in frequency. We're composed of frequency ourselves. So frequency defines how energy behaves. And in biological systems, it's like the heartbeat, brain waves, all are a frequency and they affect us. So, the human body as a frequency system now. So let's move to the human body and let's just talk about the human body. So, biological oscillators and internal resonance is what we're going to talk about. So our human body functions through rhythmic signaling. Where do the rhythms come from? Brainwaves. The heart has a rhythm. And then there's something called circadian cycles, and that's in the time, in the atmosphere that we experience. Cells, our cells, use oscillatory patterns to communicate and regulate processes. Now remember, oscillation is movement. Oscillation can create a wave pattern. And oscillation or movement processes regulate us, whether it's a calcium ion which oscillates, or whether it's water that oscillates in our body. Now, water comprises 70% of our body, and it has a transmission. It transmits vibratory information to our body. The body's biofield, which is the electromagnetic field around our body, within our body, is measurable, so we can measure it, and is responsive to external frequencies. So our body's biofield responds to a sound frequency, a light frequency. Remember, light frequencies are colors, and sound frequencies are sounds that are low or high. So the human body can be understood as a complex system of frequencies. And these are within different parts and systems, and they vibrate at specific ranges. So, according to some sources, not all, the healthy human body resonates at a frequency of 62 to 78. So, if you have a frequency between 62 to 78, according to these sources, um, and you're in a healthy state. Disease potentially starts when the frequency drops beyond that to 58 hertz, megahertz. So we're measuring in megahertz. So 62 to 78 megahertz is healthy. Below 58 gets into not healthy. And then the overall electromagnetic field of the human body is said to operate within these ranges of 62 and 68 hertz. So the overall field between 62 to 68 hertz, with each organ, each tissue, each cell, or system acting as finely tuned harmonics of this range. So when we're healthy, all our organs are also within this range. And in terms of specific frequencies, for example, our gastrointestinal system is reported to have a frequency range between 36 and 44 hertz. So we were talking about megahertz, this is now hertz. And then the resonant frequencies of standing humans have been measured to range from 9 to 16 hertz, with an overall mean value of 12.3. So 12.3 is the average human. Another study suggests that the human whole body fundamental resonant frequency is around 5 hertz. And through this, we can, and this hertz, whatever 5 hertz, can vary depending on the vibration magnitude used during the testing. So depending on the magnitude of the vibration, the hertz can vary. So it's affected by that. So we're not only affected by frequency, we're actually composed of it, constructed of it. And biological coherence rises when we're synchronized. So let's talk a little bit about these 3 terms that I said were very important for us to understand. They're principles scientific, and they're the mechanisms behind how frequency interacts with us. And these 3 words are resonance, entrainment, and coherence. So what does resonance mean? A resonant system is a system that vibrates more strongly when it's exposed to its natural frequency. So whatever frequency something is, when it's exposed to something of the same frequency, it's stronger. Entrainment. A rhythm that's dominant can synchronize weaker systems. So if there's a weaker frequency, a more dominant frequency will overtake that. And they've seen this in cardiac pacing and brainwave entrainment. or brainwave training, same thing. Now, coherence. So coherence is the orderly, phase-aligned oscillations increase system efficiency. So when you have frequencies that are phase-aligned and vibrating in an orderly manner, this can affect the efficiency of a system and improve it. And these mechanisms are measurable. They can observe these in neuroscience, in physics, in cardiology. And the resonance and entrainment are physical behaviors that can be observed in a lab and in clinical settings. And there's multiple healing applications which begin when we understand how to work with these rhythms. So here what you're looking at is a brainwave chart of somebody. And we're now going to talk about brainwave frequencies, focusing on the brain. So these are neural oscillations. We talked a little bit about biological oscillations. So in the body, biologically, now we're talking about neural oscillations and cognitive states. So brain waves are rhythmic in nature, and they create electrical patterns. And these are generated by neuron activity in the brain. So, and what we use to measure this is called an EEG, and the unit it's measured in is hertz. So, there's different categories of these brain waves, and they're labeled in Greek terms, Greek numbers. So, delta is deep sleep. And when you're in a delta frequency, in hertz, you're between 0.5 and 4 hertz. So the lower frequency range is deep sleep. Then you go from 4 to 8 hertz, and that's theta, and that's your meditative dream state. Then you have alpha, which is 8 to 12 hertz. So you're not meditative here, but you are calm and you're alert. So between 8 to 12 hertz, you're calm and you're alert. And then you have the beta, which is our thinking state, and that's between 13 and 30 hertz. And then finally you have a cognitive state where you get insight and integrate. So again, now we're in the opposite direction. We're in the higher frequency range between 30 and 100 hertz, and that's the gamma brainwave. And you'll see in the image on the side here, this individual is moving from one brain state to another. It's not consistent. It's moving up, down, up, down, up, down, up, down. And on the left, you can see the frequency in hertz. And on the bottom, you can see the time in seconds, how long it takes for that frequency to change. So in this case, this person's up, down, not consistent. But there are certain locations where the image is bigger. You'll see it bigger, and that's where they're there for a longer time. So brainwaves, as we can see through this, aren't static at all. They don't stay consistent the same. They go up and down. They shift based on your mental, your emotional activity. So what you're doing mentally, when you're thinking, they shift. When you're emoting, they shift. Your emotions play a part in your brainwave activity as well. And they respond to auditory, so sound, and electromagnetic input. So the sound you can hear, and our hearing range, by the way, is between 20 and 20,000 hertz. So it'll respond to that, what you can hear, but it'll also respond to that, what you can't hear, which comes in through electromagnetic input. And this allows for us to have targeted modulation. We can modulate, we can control what occurs, we can control what's happening with our brain states using auditory and electromagnetic input. And we know this because of this. So, cardiac coherence. Here we're going to talk about the heart and the frequency of the heart. So, the rhythmic field of the heart, by the way, the heart produces the strongest rhythmic field in the body. And it's 100 times stronger than the brain's. And some say 5,000 times stronger than the brain's. And coherence occurs here. So when your heart rhythms can be chaotic or coherent, depending on your emotional state. So depending on how you're feeling determines the rhythm of your heart. And this was discovered by the Heart Math Institute. And I've had the pleasure of talking and learning from some of these individuals firsthand. The very first time was 10 years ago when they came and did a presentation for us. And recently I'm interacting with individuals that are associated with the Heart Math Research Institute. So now, positive emotion gives us smooth, sign-like rhythms. Coherent heart rate variability is how it's measured, HRV, heart rate variability. Enhances cognition. So when we're in coherence, we enhance cognition. We're more resilient and we have a better immune function. And positive emotion drives that for us. So coherence can be induced through breathing, sound, or intention. You don't need anything else. You have your breathing capacity. You can listen to sounds and you can have an intention. Just with your own being, you can affect the coherence in your heart, in your body, and improve your, what did we say? Cognition, mental ability, your physical resilience, and your immune function, just by working with breath, sound, and your intention. So when your heart enters a coherent rhythm, the entire nervous system shifts into harmony. And this entrainment effect, it's measurable and it's reproducible. We talked about the fact that we can measure it, but we can reproduce it again and again. In fact, what affects one person will affect another person, but how it affects one person versus another person depends on the state of their vessel, their body at that time. So we talked about biological oscillations. We talked about brain oscillations. Now we're going to talk about cells themselves, the cellular oscillations. And again, oscillations is movement, vibration. And so here we're going to go into the actual cell as a vibratory system. And cells also exhibit a rhythmic behavior. They have a rhythm to them. During ion exchanges, during mitosis, during molecular vibration, when molecules vibrate, when ions exchange. So the oscillatory calcium waves, for example, they regulate intracellular communication. Cell membranes resonate with electromagnetic fields and can be influenced by external frequency. So your cells can be influenced by frequency, whether it's sound, whether it's light, they'll be affected. And so can be affected positively and can be affected negatively. So what input goes into our body through frequency, whether it's sound or light, can affect us. And studies have shown certain frequencies promote even tissue regeneration and cellular repair. For example, 528 hertz and 50 hertz through PMF can affect you. You can repair your cells. You can regenerate tissues. And cells are not only biochemical units. They are vibrational instruments. So they're not just a composition of chemicals. They also are, they have a function. They have a character, and that character is vibratory. It's like a vibrational instrument. And this has a direct implication for tissue healing, for inflammation, and for your metabolism too. So you can affect your metabolism through frequency. So we talked about the cells now. We're going to talk about the human biofield and the electromagnetic fields surrounding the body. So that's the human biofield is a field that surrounds the body. It's unseen. You can't see it, but we now have equipment that can see it. The ancients called it the aura. So biofield science, and there's a science now, biofield science is recognized by an organization called the National Center for Complementary and Integrative Health, NIH. The human body emits a measurable electromagnetic field, and this is what we're calling the biofield. It's detected via something called squid magnetometers. ECG, EEG, and other instruments also detect this. And some of you may have had an ECG exam or an EEG exam for various reasons. There's also energy-based modalities out there which detect this field energetically. And these are Reiki, sound therapy, and PEMF technology. And these modalities may work by interacting with this field as well. Although we can't demonstrate this yet fully, we know there's something to it. So back to the biofield science that's recognized by NIH, what we know is that Western medicine can see interactions between chemicals, but emerging fields of science out there now are recognizing also the subtle energetic exchange, the unseen exchange through different means now. And this biofield represents this bridge between the physiology, the physical nature we have, and the vibrational input that enters us through the unseen reality. So let's do a summary now of internal frequencies. The body, we now understand, functions through multiple overlapping systems that oscillate, rhythmic systems. And we know that, we discussed that. We talked about the cellular system, the biological system, the rhythms in the brain and the heart, and synchronization of systems coming together of the same leads to health, clarity, and resilience. That was the coherence we talked about. Now, disruption of these rhythms, so chaotic, rhythmic inputs, can also cause trauma and can be due to trauma. So if you have a disruption in your rhythm, it could be caused by trauma, and it could be due to trauma that you have, whether it's stress in the environment, whether it's emotional trauma. And this leads to dissonance. So dissonance being the opposite of coherence. And what I want to propose is there's frequency-based tools out there that offer a path to restore the coherence. And the summary of this is really that we are rhythmic organisms. We're rhythmic beings. We're frequency beings. And healing is not only about adding energy, it's also about restoring harmony within existing rhythms. So What kind of scientific evidence is there about some of these things we just spoke about? And we're going to go into it briefly right now. So PEMF, we used that word before, and PEMF stands for pulsed electromagnetic field therapy. Pulse electromagnetic field is PEMF. And PEMF is a system that applies low frequency electromagnetic pulses, so pulsating frequencies to the body. And they've validated the benefits of this, and it includes bone regeneration, and there's FDA approved products out there for non-union fractures. So we can regenerate bones. We can reduce pain, pain reduction, inflammation modulation. We can reduce inflammation, we can reduce pain, or we can modulate inflammation. We can enhance the energy of cells through PEMF. On the frequency ranges that they've worked with are between 1 and 100 hertz. And 1 and 100 hertz is also the higher brainwave that we talked about. So there's from the environmentalists, we have Markov MS in 2007 that said pulsed electromagnetic field therapy is the history and state of the art and future. So this was in 2007, and we're already working with it. And there are so many other studies we can go into and examine them each in future sessions. And PEMF is one of the most thoroughly studied frequency-based therapies, and there's rigorous clinical trials and FDA approvals in orthopedics and other fields to show us that it actually does make an effect. It does work. So here we're going to talk about something called cymatics, just to demonstrate for you. And cymatics is the study of visible sound and vibration. So remember we said unseen sound and light? Well, we're going to show that it's provable that it affects matter through something called cymatics. And sound frequencies basically produce geometric patterns in media. So any media, water, sand, particles, and therefore our cells. And so I'm going to just play this little video. And remember, higher frequencies create more complex structures. I'm going to play this video for you so you can watch it.
Chladni discovered that when he spread sand on metal plates and then vibrated the plates with a violin bow, the sand arranged itself into patterns. Different geometrical forms appeared depending on the vibration produced.
So there's the video. I'm going to go back to the other original presentation for you. Just to understand cymatics, cymatics is an ancient Greek word, and it means wave. So it's a subset of model vibrational phenomena. And you saw in the video, the term was coined by Swiss physician Hans Jenny, who lived from 1904 to 1972. And typically the surface of a plate or a diaphragm or a membrane is vibrated, and regions of maximum and minimum displacement are made visible in a thin coating of particles. And this could be a paste, it could be sand, it could be liquid, and different patterns emerge depending on the different sounds that are entering that medium whether it's water or whether it's sand. And different patterns are created. And in the excitatory medium, depending on the geometry of the plate and the driving frequency, a different pattern forms. So depending on the sound coming through, a different pattern forms. So every sound has a different pattern. And the apparatus can be simple. It could be a Chinese spouting bowl, in which copper handles are rubbed and cause the copper bottom elements to vibrate. And it could also be something called a Chladni plate, and also a cymoscope. And so there's different mediums out there we can use to demonstrate these. And these visible structures show us how frequency can organize, form from the cells to emotions. Cymatics offers a bridge between physics and form, showing us frequencies organizing principle. Okay, so next, let's talk a little bit more about the scientific evidence for cellular response now. We talked about PMF, we talked about the cymatics. Now, how do we know it affects cells? So, low frequency EMF now, EMF is electromagnetic frequency, is shown to enhance osteoblast proliferation. So, what is osteoblast proliferation? So, osteoblast proliferation refers to the process by which osteoblasts, what are osteoblasts? They're bone forming cells, so cells that form bones, and they increase in number through cell division. So, this process is a critical step in bone formation and remodeling, and it allows for the expansion of the osteoblast population, which are the bone forming cells. So when they divide, we have more bone forming cells. So this process is necessary for the synthesis and secretion of the organic matrix of bone, including collagen type 1, and for the subsequent mineralization of this matrix. So this movement is what creates these bone forming cells and creates this process called osteoblast proliferation. And 528 hertz is associated with DNA repair. And we know this from Gariev and Lipatov, who did an experiment in 2001. And then brainwave entrainment, remember we were talking about the brainwaves? We can entrain our brainwaves. What's entrainment? A more powerful frequency takes over a lower frequency. So we can train our brainwaves through something called binaural beats. And that you can improve focus, you can improve mood, and you can improve sleep with such brainwave entrainment and other things. But this study covers sleep, focus, and mood. And frequency can modulate calcium signaling, gene expression, mitochondrial activity, which is so important for us. And these are not speculative things. This is tested and in labs, and we know this now. And we're seeing real changes in gene activity, membrane potential, and healing rates. All these in response to vibration and frequency. So, clinical and lab studies, let's go into that a little bit. There's multiple lab studies, and we're only going to talk about a few, and we're going to talk about in neurofeedback. So that's entrainment of brainwaves. They can use frequency for ADHD, for PTSD. Using PMF, they can control pain, arthritis, fibromyalgia, and that's through ultrasound therapy and high frequencies. And we can mechanically stimulate deep tissue healing through music therapy using which is used in palliative care and is used to reduce anxiety. And this has been done in double-blind studies to confirm things. And so neurofeedback is basically known as neurotherapy or EEG biofeedback, and it's applied neuroscience technique used to train or retrain the brain to function more optimally by encouraging the brain to learn patterns of electrical activity associated with normal or optimal function. It involves measuring brain waves and providing feedback to the individual, which helps them modulate specific brainwave activity through behavior, modification, and learning processes. And this non invasive neurotherapy typically collects brain activity data using electroencephalography, encephalography, EEG. So I've actually had EEGs because when I was younger, I used to have seizures, and they put these electrodes on your brain, and they then record what's happening with your brain waves. And it can be used to address reported symptoms, improve health and well-being, and it can enhance human performance. And as this evidence grows, and I've got a couple of citations there for Rohan ML in 2004, as early as 2004. The previous one we talked about was 2001, 2007, 2012. We're in 2025 now, so it's advanced since there. And I mentioned seizures, and you can see neurostimulation for epilepsy. And the evidence grows. Frequency is moving from the periphery to the center of therapeutic innovation in neuroscience, in oncology, and in chronic disease. So it's not woo-woo anymore. They can demonstrate this and they can show this to us. So why does it work? I'm going to talk to you about why it works next time.